In today's session, we would be specifically talking about the unsupervised learning techniques. So, today's session would primarily focus on the introduction to unsupervised learning. We would talk about some applications, we would talk about the evaluation criteria, we would also talk about the types of clustering, the types of unsupervised learning techniques, where we would primarily focus on two major techniques, which are partition based clustering and which are basically hierarchical clustering. And we would also talk about some key metrics which are involved in both these techniques. To start with, as you can see in this particular diagram, which is a very classical example of unsupervised learning. If you remember, in supervised learning, we used to provide both input as well as the labels associated with that inputs. So, in a way we were having both the input as well as the output, or we used to call them as an examples. Now, during the training we used to learn the function between the input and the output. That was the procedure that we used to follow in the supervised learning. That means there was someone to supervise you, the answers to the questions were present while the training, right. So, in unsupervised learning we have only the questions, we do not have the answers. This diagram also shows, I have used the same diagram in the supervised learning as well. So, here we want to train certain images, say Tom and Jerry. Now, here we only have the images, right, we do not have the labels associated with it. So, I do not know. So, in other words, we only have the data, right, and now based on the data I have to do something, I have to find some similarities in the data so that I can group them, and later on I can name those groups. So, that is how the unsupervised learning would be happening, right. So, the goal of unsupervised learning becomes what? To discover the patterns, to discover the hidden patterns in any unlabeled data. So, that is most important, that we do not have labeled data, I only have my data, right. I do not have the answers, I do not have the examples with me where I can train them, right. And the model learns through training itself from the data. So, there is no one who is going to supervise it. So, somehow the algorithm needs to look into the data, find similarities among the data, the statistical similarities among the data, and then they would be these algorithms going to group that data, right. And then later on we can, once that groups are formed, we can name those groups, we can identify that the similar kind of items or similar kind of data goes to the similar groups. Right. So, where exactly this is useful? So, it may not have any labels, but still have to detect the patterns. So, it becomes very useful in those applications where we do not have the labels, we do not have the answers, but still I want to solve those answers, solve those questions, right. So, if we talk about the unsupervised learning applications, there are many applications. To name few of them, it could be the customer segmentation, which is basically a very well known application in marketing and the e-commerce, where the companies like the Amazon, they do what? They group customers based on their buying behavior. They does not know the entire information about the behavior of the customer. So, looking at the data of the customer, they see what they are buying and they try to understand the buying behavior of the customers, how they spend, what their spending habits, and how they are browsing. So, in a way they are trying to understand the habits of the customers, and based on those understanding it can come out with their own business propositions for the customer, which actually suits to that customer, right. Similarly, so without predefined labels, so we are going to give what personalized offers and the interest sales to these kind of people whom we are studying, right. Similarly, another case could be recommendation systems, the way the Netflix, Spotify, YouTube does. So, what they does? So, they are these platforms group the users with similar preference to recommend the movies, right. Again the same kind of thought process. So, they are again studying the behavior of the customers in terms of what kind of movies they prefer, what time they are watching the movies, and what their taste of the movies are. So, I mean, this is the way it can study the customers, and ultimately it can provide the recommendations to those customers, right. Another applications could be the medical diagnosis and the anomaly detection, where again the hospitals trying to identify the the abnormal patients reports by detecting the data points, right, that differs significantly from the normal health patients, right. So, again another application could be your market based analysis, which is a classical example retail analysis, where the retailers trying to discover which products are frequently purchased together, right. So, this is a rule based systems actually. So, they want to optimize the store layouts and cross selling strategies, right. So, the ample of examples that you would find in real world that actually requires the unsupervised learning intervention, right. So, one of the approaches to unsupervised learning is something called clustering. So, clustering is what? It is nothing but the task of dividing the entire data set of the population, the data points that I have, into number of groups, right. And each group would classify those elements or the data points which are similar to each other. So, the items in the same group would be as similar as possible. So, when I talk about similarity, there has to be certain criteria. So, most of the cases it is distance between the data points, nearness of the data points becomes criteria for similarity, right. Similarly, the data points which are into different clusters or different groups, they should be as dissimilar as possible. So, we use two basic terms, one is the intra-cluster similarity and one is the inter-cluster similarity. So, inter-cluster similarity means the closeness between the data points of the same group should be as near to themselves. So, they should be as similar as themselves to each other. Similarly, the data points into the different groups should be dissimilar. So, we normally call this a inter-cluster similarity, right. So, we would talk about these what exactly is required. So, obviously, when I would talk about intra-class similarity, it should be very high, and when I would talk about the inter-class similarity, again it should be less, right. So, as you can see in this particular example, we would actually talk about something called the evaluation matrix of clustering, because every algorithm, whether we talk about supervised learning techniques or the unsupervised learning techniques. So, every algorithm, there has to be certain ways by which I should be able to understand what is the performance of those algorithms. So, evaluation metrics, that is what we are trying to cover. So, there are two basic evaluation metrics for clustering or for the unsupervised learning techniques, and one of them is called the inertia. So, it does tell you what? It tells you about how far the points within the cluster are. So, I am talking about within the cluster, if suppose I have data points. So, each of the data points are how far each of the data point is from its centroid. Centroid means the center point, right. So, each of the data points, so we would take the distance with respect to the centroid for each every data point within that particular cluster, and we would add those distances, right. And the distances between them should be as low as possible. That is what my objective is, right. The distances between the two clusters could be this particular example, where you can see that again if there are two clusters, two groups. So, I would again like to see like the point in one cluster and the point in another cluster. So, how they are, so what is the distance between them. So, the distance between the centroid of the two different clusters is called what? Inter-cluster distance, right. So, in this case obviously I would like to maximize the done index. So, this is another say criteria which is very important, where we talking about the data points into the different clusters. So, one is inertia, which talks about the data points or distances between the same cluster, and other is a done index, which talks about the data points into the different clusters. So, what is the distance between the two centroids of the different clusters. So, now let us talk about the different kinds of clustering techniques which are popular in unsupervised learning. We will then focus on two of the more common techniques. So, starting with partition based clustering, which is a very popular technique of unsupervised learning. So, here the basic idea is what? So, basic idea is very simple. You divide your data points into k predefined clusters. Actually, we cannot know what would be the number of clusters that my data point would belong to. So, this also becomes one of the limitations of these techniques. So, here we have to predefine the value k, that is what is the number of clusters I would like to cluster all my data points. So, we divide the data into k predefined clusters, where each of the data point belongs to exactly one of the clusters, right. So, I mean these clusters might be anything. For example, I want to cluster my documents into, say, suppose documents related to sports, documents related to entertainment, document related to, say, suppose other kind of business talks or anything else. So, this is what we should know the clusters in advance. So, what is the number of classes that I want my data points to classify. So, that is where I would be using the partition based clustering. So, some of the very common techniques in partition based clustering includes your k-means techniques. Again, k-metoids is also very popular, right. There is something called Clara techniques. So, we would be primarily focusing in this lecture on the k-means later on. Then again, clearance is also one of the popular techniques which is used in partition based clustering. So, when we are going to use it? So, we use it when the number of clusters is known in advance, right, which in real scenarios is not always the possibility. How would I know that since I do not have the labels and since I do not have the classes also. So, in most of the cases I would not be having the number of k points known to me. So, what is the number of classes I would cluster my data points is something which, if it is known, if you know that I would always like to cluster all my points into these classes only, then you can go for partition based clustering, and specifically k-means could be a very efficient technique, right. Another method is something called hierarchical clustering. So, name itself tells you what that there has to be some kind of tree like structure. So, here we create a tree like structure of the clusters. So, clusters gets formulated in tree like structures, we call them as dendrograms actually. Yeah. So, here I mean there are two basic methods which are very common in hierarchical clustering. One is agglomerative techniques, which is actually a bottom up manner. So, we form the clusters in a bottom up manner. So, we will talk about this in the coming slides. So, there are again techniques like single linkage, your complete linkage, and the average linkage techniques and agglomerative techniques. Similarly, there is a method which is quite popular, which is called the Birch method, right, which is a very popular method in hierarchical clustering. Then another technique which is known here is divisive clustering, which is basically a kind of top down approach, right. So, one was the bottom up approach. So, in the top down approach, how the clusters gets formulated. So, we start with all the data points at the top, and then we keep on dividing those clusters into subgroups as we go from top to down. We will talk about the divisive clustering later in the slides. So, again DINA is one of the very popular algorithms which is called divisive analysis clustering technique, which is a known divisive top down approach. So, when we are going to use it? So, when obviously you would find some kind of hierarchical structuring which is present in your data, which is clearly visible when we know about the data. So, in that kind of scenarios, I mean the hierarchical clustering would be more useful, right. Another could be your density based clustering. So, here the idea is what? The clusters are formed when the data points are densely packed. So, there could be the scenarios, right. So, the algorithms like DB scan, SDB scan, optics, they are very popular techniques in the density based algorithms. So, again this would be good for the irregular shaped clusters and where the decision I mean there is a lot of noise involved into it. So, in that scenarios the density based clustering would again be very useful. Another would be the model based clustering, right. So, the idea over here is that we assume the data is generated from a mixture of probability distributions, right. So, it can be the Gaussian mixture models, which is very popular. It can be the expectation maximization problems. It can be the Bayesian Gaussian mixture models, latent class analysis. So, these are popular methods which are used in model based clustering. So, again it produces what? The soft clustering techniques, soft clusterings groups in this particular cases, which are based on probabilistic membership, right. Another approach could be something called grid based clustering techniques, where we divide the data space into into fixed grid cells, right, and the clusters are dense cells over here. So, algorithms like Sting, wave cluster, click, OptiGrid, these are some of the popular grid based clustering methods. So, again they are very efficient for the large data sets. So, in this lecture we would primarily focus on the partition based and the hierarchical clustering. We would not talk about rest of the techniques. There are again a few more other clustering algorithms like spectral clustering, where we use the eigenvalues of similarity matrix to reduce the dimensionality between the clustering, and they are very effective for non-convex kind of cluster shapes. It can be the constraint based clustering, where the idea is that we use the clustering under the user defined constraints. So, the constraints would be defined by the users. So, again it can be domain specific clustering tasks where it can be used very more, right. So, as I told you that we would focus primarily on the partition based clustering in today's session, and then we would also talk about something called the hierarchical clustering in the next session, right. So, as I told you that the partitional clustering divides your data points into non-overlapping groups. That is the important aspect. So, obviously, when you are dividing the groups, so ensure that a data point should not belong to at the boundary of the two groups. A data point has to belong individually to one of the groups only. So, there cannot be overlapping groups. So, that is the basic thought process. So, how do we divide it, that we would see, right. So, obviously, we need to specify, as I told you, one of the limitations of this particular algorithm is that I have to predefine the number of clusters, right, which is nothing but a integer value, we call it as a k value. So, I told you like the two popular methods which we would be covering in this particular case would be the k means and something called the k means plus plus algorithm. So, it is a non-deterministic approach, like why? Because it could produce different results from the separate runs, even if you run it on the same input. So, this is a non-deterministic approach. So, every time you want to run this algorithm on the same input, you might see different clusters being formulated. So, that is what we call it as a non-deterministic approach. Otherwise, had it been a deterministic approach, so every time we would apply the same algorithm, the same input, you can assure that the output would be similar. So, this is a non-deterministic approach. So, some of the strengths of partitioning based clustering could be that they work quite well when the clusters are spherical shape, right. So, in that cases it has been experimentally found that these tend to work better. They are scalable with respect to the algorithm complexity, which is again one of the greatest strengths of this particular techniques. Some of the weaknesses might include that they are not kind of well suited for the clusters where the complex shapes and different sizes shapes are involved, and where the data clusters are quite complex in its presentation. So, they often break down when used with the clusters of different densities, right. So, these are some of the strengths and the weaknesses that we understood. Now, as I told you that we would primarily talk about one of the very popular clustering technique, which we call it as a k means clustering technique, and by the name itself, as you can see that k is the number of clusters that I need to predefine beforehand. So, that is what k over here it means, right. So, as you can see, as it is a partition based cluster, so it would divide the data points into k distinct non overlapping clusters, right. So, you must first specify, as I told you, the number of clusters, which is an integer value, right, and the objective I told you is to minimize the inter cluster variance or the squared error function, right. As you can see, these are some of the examples where the clusters are been shown, like how the data points can be clustered into different groups. So, we would now specifically talk about the k means clustering algorithm, that how that algorithm works, and then we will take one working numerical example to understand the entire end to end working of this algorithm, right. So, if we talk about the algorithm, so it would cluster, so I am talking about the steps now. So, clusters the data into k groups, that is the first. Then what we do is we select the k points at random as a cluster centers. So, if we have k which has been predefined, so what I need to do first is I have to select the k points from my data set in a random fashion, which would be taken as initial clusters, right, which would be taken as initial clusters, right. So, then what we do is, as a third step, we would assign the objects to these chosen initially chosen clusters, closest cluster center according to the equivalent distance function. So, here the distance, in order, I told you that there has to be some mechanism by which I can decide the closeness of the data point. So, there can be different ways that different distance metrics which are used, like one of the popular distance metrics is your equivalent distance matrix. So, with respect to all the data points, I would calculate the equivalent distance of the different data points with respect to the initially chosen clusters, that is the centroid points, right. Now, once this is done, and this has to be done for all the points, now we would calculate the centroid or the mean of all the objects in each clusters, right. And once this is done, this is the fourth step, and then what we are going to do is we are going to repeat these steps, that is steps 2, 3, 4 until the same points are assigned to each cluster, till this mechanism would continue till the clusters or the data points does not change their clusters, right, or in a way the centroid gets optimized or centroid gets fixed. So, this is the steps under which the entire k means algorithm works. So, we would understand this algorithm with the working example over here. So, just to take an example, I have taken one of the examples where I have taken the data points, right. As you can see in the slide, so what I have taken the 8 data points over here x, y, which are present in the 2D space, and I want to divide or classify these data points into 3 clusters. So, I have specified the value of k is equal to 3 over here. So, my data points, as you can see, I have named them with the points A1, A2 to A8 data points, and where the x and y values have been given, right. So, as I told you, the first step was to choose the initial clusters based on the value of k. So, here the k was 3. So, I have to randomly choose 3 data points as initial clusters, and this could be any data points. And later on we would understand that this also becomes one of the limitations of the algorithms, the way I am choosing these data points, that is the random points which I am choosing, right. So, and that is the reason I told you that whenever you are going to run this algorithm, every time you are going to run this algorithm, it would be it would not deterministic in the sense, because since every person would have when it is choosing data points, it could be random data points. So, now coming back to the example that I was showing. So, here I have taken A1, A4 and A7 as the initial cluster points, right. Now, as you can see in this particular example, now I would start calling these data points as a clusters, right, the 3 initial clusters C1, C2 and C3 for example, right. Now, the distance function between these two can be defined, as I told you, it can be equivalent distance, it can be anything. For simplicity, I have taken absolute differences, that is x2 minus of x1, the absolute sum, and plus y2 minus of y1, that is the absolute sum that I have taken, right, just for simplicity. You could have taken other distance metrics, it can be equivalent distance, it can be many other Hamming distance could be used, many other techniques which could be used as a part of the distance matrix. Now, what we need is, we now would apply the k-means algorithm to find the 3 cluster data centers, right. Now, again coming back to this example, iteration 1 I would talk about now, right. So, what I am going to do is, I would calculate the distance of each data point from each of the center of the 3 clusters. As you can see that what I have done is, for each of the data points, I am calculating the distance of these initially chosen clusters, 3 clusters, that is cluster C1, So, the data point, for example, A1 with respect to the cluster 1, 2, 3 similarly. So, as you can see that I am calculating distance between say A and C1, right, for example, and I have calculated the distance. I hope this is pretty simple, the pretty simple calculation over here. So, in similar case I have calculated for with respect to, so I am calculating the point A with respect to C1, C2 and C3, as you can see. So, these are the 3 points which I have calculated just to give you a reference point, right. Now, what I am going to do is, as you can see in this particular table now I have built up a table where I am doing what? I have calculated the distance of all the clusters which I have taken, that is C1 with respect to all the points, C2 with respect to all the points and the third column with respect to all the points, right. So, all the clusters have been distance have been calculated, and as you can see based on those calculations, if you have understood, right, that the we could see in the last column that the clusters have been assigned based on the closeness of it, right. So, for example, if I take the first row, so it is the C1 which is the smallest value, and therefore, the cluster C1 gets assigned to it, and similarly you can understand the rest of the values in this particular table. So, in a way these clusters have been assigned in this particular table. Now, next what I have done is, I would now do what, since as you can see that how many points now belong to cluster 1. So, as you can see from the previous table also that only A1, that is a 2, 10, this is the only data point which belong to cluster 1. Similarly, in cluster 2 there were A3, there were A4, A5 and then the A6 and also the A8. So, the majority of the data point actually belong to the cluster 2, and in cluster 3 only again 2 data points were belonging. Now, what I need to do, as I told you, as a part of the next iteration, I have to calculate the mean of each of these data points where the clusters have been done. So, in a way I have to redefine the clusters. So, initially those cluster points were chosen, I have to now what? I have to redefine those cluster points. Now, recompute the new clusters, that is what we need to do, right. So, what I have to do is, just for an example over here, you can see I have taken point A, since there was only one point in cluster 1 A1, and therefore nothing could be done about it. So, the cluster would remain same, and the center for cluster 2 there were a good number of points. So, I have taken the mean for x as well as the y, and as you can see the average point have been taken. So, new cluster which has been defined now would be 6, 6, and similarly for cluster 3 the new center point has been defined, right, where the new cluster came out to be 1.5 and 3.5. Now, this is the another iteration I have table which I have shown. So, these are the reassigned clusters. As you can see now the clusters have changed. Initially only 1 point was in cluster 1. Now, there are what, more than 1.2 points which are in the cluster 1. Similarly, the clusters have changed. So, this iteration would continue till these clusters get optimize. As you can see, I have done the same step again, right, where I have calculated the cluster points again, recalculated them. Now, the 3 new clusters have been defined again, C1, C2, C3, and this would continue till the cluster gets optimized. So, what we will do is, in the next session we would start talking about some of the metrics related to the k-means algorithm or the clustering method as such, and we would also talk about the hierarchical clustering in the next session. Thank you everyone.